Hello, my name is Marisa Fernandez, and I will be presenting my project on validity and reliability of clinical outcome measures for oculopharyngeal muscular dystrophy. I worked with Dr. Sarah Yusof this summer at the University of New Mexico for my project. So to start, I would like to first go over what exactly is oculopharyngeal muscular dystrophy, or OPMD for short. OPMD is a rare autosomal dominant progressive myopathy that affects the swallowing muscles, eyelid muscles, and proximal limb muscles. It is caused by a short triplet repeat expansion of GCG in the PAB-PN1 gene that codes for a nuclear protein ubiquitously expressed, which just means that this codes for a protein that is found everywhere in our bodies. Patients are generally not affected until after their 5th decade of life on average. The symptoms of OPMD include dysphagia, ptosis, and proximal limb muscle weakness. Dysphagia, or trouble swallowing, can be so severe later on in life, as the disease progresses, that the patients will require a feeding tube, or otherwise they would die of starvation because they can't swallow their food anymore. The ptosis, or droopy eyelids, can bother the vision of some patients if their eyelids droop too low. For proximal limb muscle weakness, it can progress to the point of needing an assistive walking device. For diagnosing OPMD, physicians can do a couple of things. During the patient history and exam, if it comes up that the patient has several members of their family that are already positive for OPMD, a diagnosis of OPMD is more likely because this is an autosomal dominant disease. A muscle biopsy of the swallowing eyelid and proximal limb muscles will show intranuclear inclusions that are specific for OPMD. If a patient has these intranuclear inclusions that are shown in this photo, this is an automatic diagnosis for OPMD. However, a DNA test is the most common and definitive of these tests. DNA test will show a GCN expansion in the PAB-PN1 gene. OPMD is considered a rare disease according to the Rare Disease Act of 2002, which classifies a rare disease as anything affecting fewer than 200,000 people in the U.S. However, as you can see in these statistics, there are several large clusters of affected people around the world. The 3 biggest clusters that are currently known are a population of French Canadians, a population of Burkara Jews, and a population of Hispanics in New Mexico. Because the disease affects such a large portion of Hispanics in New Mexico, it is a very important disease to study here at the University of New Mexico. This map here shows where the largest groups of people affected are by OPMD that are currently living in New Mexico. So some of the questions I had at the beginning of the summer after learning about OPMD were the following. What exactly is the pathogenesis of OPMD? How is genetic testing for the disease done? How do they create animal models to study the disease? Is a cure possible? What are outcome measures that can best assess disease progression in OPMD most accurately and effectively? This last question is what I focused my summer project on with my mentor, Dr. Yusuf. I will now go over my project. Right now, it is difficult to design clinical trials to help study possible therapies for OPMD and to study the disease in general. This is because currently there is a lack of established outcome measures that can properly assess disease progression. While ptosis and dysphagia are the main markers of progression in muscular dystrophy, they aren't practical to measure because many patients undergo surgery to fix them in order to make their lives better. Patients can receive Botox injections to make swallowing easier, they can undergo esophageal dilation, or they can get eyelid surgery to raise their eyelids, and several other procedures to better their quality of life. Most OPMD patients get at least one of these procedures done, and therefore other outcome measures should be defined in order to accurately measure disease progression in OPMD. Because of the challenges in outcome measures, we looked into measurements of proximal limb muscle weakness, as this is another symptom of OPMD. In OPMD literature, we found that the 6-minute walk test is feasible in Duchenne muscular dystrophy and myotonic dystrophy type 1. We chose this test because it has shown to be valid and reliable in these diseases, and it is one of the safest tests in the literature as it's easy to do, well tolerated by patients, and is most reflective of daily life compared to other tests according to the American Thoracic Society. For our methods, we matched 26 OPMD patients with 26 control participants. Each participant completed a series of strength and functional measures and a series of patient-reported instruments about physical function and mobility. OPMD participants also returned for a second visit 2 to 8 weeks later, where they repeated each test in order to assess retest reliability. The strength and functional measures used are listed here. They were manual muscle testing of the neck, shoulders, wrists, hips, knees, ankles, and we also did grip measurement strength using the Jamar Plus digital hand dynamometer. We also did the 6-minute walk test, the 2-minute walk test, the 4-meter walk test, the 10-meter walk test, timed up and go test, and the stair climb test. The patient-reported instruments used are listed here as well. The NeuroQual upper and lower extremity short forms, the PROMIS physical function short form, SF36, the Sydney Swallow questionnaire, and INQUAL. Here is a table showing the clinical and demographic characteristics of the study sample. An item of note here is again the large amount of patients who have received some type of surgery for their muscular dystrophy. As you can see here, 61.5% of the participants underwent eyelid surgery beforehand, which again shows how eyelid measurement is not a practical tool. Here's a chart highlighting comparisons of outcome measures between all 26 participants versus their controls, showing the mean scores for strength and functional measures and the patient-reported measures. For the 6-minute walk test, which is what we are ultimately interested in, we found that the mean score for OPMD participants was 387.4 meters, and for control participants, the mean score was 463.4 meters, with a p-value of 0.0023, which shows that there is a significant difference between OPMD participants and controls for the 6-minute walk test. Here is a chart showing the reliability of the different measures in terms of test and retesting. This is for the OPMD patients from their visit 1 versus their visit 2, 2 to 8 weeks later. Looking at the 6-minute walk test, we can see that this test has strong and significant test-retest reliability with its Pearson correlation coefficient of 0.94, almost a solid 1, and a p-value of 0.000. So for our discussion, we found that the 6-minute walk test does in fact have a strong test-retest reliability, as shown in the previous slide, for OPMD patients. We also found that the 6-minute walk test correlated significantly with manual muscle testing and a couple other measurement tests, such as the PROMIS physical function test short form. These correlations show that the 6-minute walk test does in fact have convergent validity. We also found that the 6-minute walk test was lower in OPMD subjects versus controls, which demonstrates known group validity. Therefore, we can say that the 6-minute walk test may be a safe and practical instrument to use for OPMD trials, as it has shown validity and reliability. However, future tests are needed to investigate responsiveness to change over time, as this was only a cross-sectional study. So, many of my questions that I started the summer with were answered through speaking with my mentor and through reading the current literature on OPMD. But now, by the end of the summer, there are still many unanswered and unanswerable questions remaining for me about OPMD. I have listed some of the questions here. So far I have, why is OPMD selective for swallowing, eyelid, and proximal limb muscles? As mentioned earlier, the mutation in PADPN1 causes an error in creating the nuclear protein found everywhere in the body. So why does this disease only affect these listed muscles and not others? The question is still being answered. Another question I had was, biotech pharma has found that their drug Trehalose may work against the mutation in their latest study, which is very hopeful for future OPMD patients. However, what they didn't answer is what this mechanism is. So my question is, what is the mechanism of Trehalose versus OPMD? And finally, my last question is, what is the origin of the mutation? There are still many remaining questions about OPMD, and I hope they are all eventually answered in the future. Here are my resources, and thank you for your time.
Okay, so that was a great presentation. You focused your research on understanding the reliability and validity of clinical outcome measures. Can you define for the listeners what reliability and validity are?
Sure. Validity is just making sure that you are testing exactly what you believe you're testing. So in our case, we used the 6-minute walk test, which tests how far someone can walk within 6 minutes. But our goal was to measure how severe the OPMD patients, or the severity of their disease. So they didn't walk as far as control groups. And for reliability, reliability is performing a test and then performing a test again and getting the same result.
Good. So why will it be important to assess in a future study the responsiveness to change over time of the 6-minute walk test?
So for our test, we only measured the 6-minute walk test at one point in these patients' lives. They performed the test once. But what's more important is to see if this test is a good one, if the patient's disease progresses and gets more severe over 10 years, and then they perform the test again, their results should change over time.
Okay, good. So in your methods, you showed the results of many comparisons between OPMD patients and controls in terms of the results of their outcome measure testing. What statistical approach did you use to make those comparisons?
For our analyses, we used the 2-sample t-test.
Very good. You mentioned autosomal dominant in terms of the inheritance pattern of OPMD. Can you explain what that means?
Sure. It just means it's dominant versus recessive, which means that you have a 50% chance of passing it on.
If you're affected.
If you're affected. If a mother is affected, she has a 50. Oh yeah, or a father.